Hello friends, today's topic of discussion is Mach number. It is a very simple term that is used in the field of aerodynamics commonly. Mach number is a dimensionless quantity, which means it has no dimensions. Mach number is a very important term that is used in aerodynamics. Aerodynamics is defined as the study of how gases react with moving bodies. These moving bodies range from an aircraft to a simple bullet that is fired from a gun. It represents the ratio of flow velocity past a boundary to the local speed of sound. The main thing that we need to keep in our mind while calculating Mach number is that this boundary can be either internal or even external. From the definition of Mach number we get m equals to v by a. Here v represents the velocity of the object or the velocity of aircraft and a represents the sound velocity, which is given by the formula under root gamma rt. E equals to 346 meter per second for standard temperature and pressure conditions or 336 meter per second for sea level conditions. Sound velocity varies with temperature. In aerodynamics, ratio of object speed by speed of sound is Mach number. Mach number is divided into four categories: subsonic, transonic, supersonic and hypersonic. By definition of Mach number, an object is defined to be moving with Mach 1 when speed of the body is equals to speed of sound. Then v equals to a, m equal to 1. The Mach angle is the angle that a shock wave makes with the direction of motion as determined by the velocity of the object and velocity of shock propagation. For supersonic and hypersonic flows, some disturbance is created and transmitted downstream. This is called a shock wave. It is generally in the form of cone. As we can see here, this is called a typical shock wave. And it is given by the formula mu equals to sine inverse 1 by m. Here m is the Mach number. This is a simple representation of number line showing Mach number flow regimes ranging from incompressible flow, subsonic flow, transonic flow, supersonic flow, hypersonic flow and even hypervelocity flow. One should keep in mind this number line whenever calculating Mach number of a typical body. Now we talk about the subsonic flow. It ranges for all the Mach numbers less than 0.8 with the speed of 274 meter per second. These are generally propeller-driven and commercial turbofan aircrafts. They have high aspect ratio. Rounded nose and leading edges are present. This is a typical subsonic aircraft. Here we can see that rounded nose is present. Now we talk about the transonic Mach flow. It ranges from 0.8 to 1.2 Mach number with a speed of 274 meter per second to 412 meter per second. These have swept wings in order to delay drag divergence. They are made in adherence to Whitcomb rule to delay drag divergence. This is a typical transonic airfoil. The supersonic Mach flow regimes from 1.2 to 5.0 Mach number with a speed of 412 meter per second to 1715 meter per second. These aircraft show large differences in their aerodynamic designs. They have got sharp edges, thin airfoil sections and moving tail planes. These include the Starfighter as well as the BAC. Here we can see the edges are sharp and the airfoil sections are very thin. The hypersonic Mach flow regimes range from 5 to 10 Mach with a speed of 1715 meter per second to 3430 meter per second. These are made up of cooled nickel or titanium skin, which are highly integrated due to interference effect due to the radial pressure difference that an aircraft goes when it falls in aerodynamic pressure. It shows non-linear behavior with very small wings. X-51A, Wave Rider and Hypersaur are part of hypersonic flow regimes. Here we can see a typical US military aircraft with small wings. This is the Hypersaur aircraft, moves under hypersonic Mach number. Now we talk about hypervelocity flow region. This ranges approximately from 6700 meter per hour, 11,000 km per hour, 10,000 feet per second or all the numbers that range above Mach 8.8. Hypervelocity refers to the velocity in the range from a few kilometers per second to some tens of kilometers per second. Rocketry and space vehicles fall under the hypervelocity flow region. In the figure given below, you can see a typical hypervelocity projectile. Its shape and structure with the use of materials is formed in the presence, keeping in mind that how an object would be moving in hypervelocity flow region. With this, I think all your doubts on Mach number, Mach angle and different type of flows would be clear and you would be able to imagine that which aircraft flows in which region of Mach. Thank you.